Thank you, Garth. Thank you, Rachel. And again, thanks to all the students for joining. So today's presentation is going to be about Autodesk generative design. So I'd like this to be an open discussion, pretty small group. So if you guys want to unmute yourself and ask a question, go ahead and do that. And we'll also use the chat window. So if you have a question in there, I'll try to keep an eye on that as well. So real quick, those of you that didn't join last week, so my name is Dan Bonic. I work at Autodesk in the education group. Been doing CAD, mechanical design, engineering since the late 80s, 28 years teaching, consulting on CAD products. And I'm also a published author. So I have 25 books on Autodesk and mechanical 3D CAD packages. So the most important part, in the chat window, if you could put in, and if you have any CAD experience, you could just list that. That would be great. And let me know if you have any generative design experience. That would be helpful. Oops, sorry, went back one too far. So if you could do that for me, that would be great. Just type it in the chat. Again, that gives me a basis where I understand some of the questions are coming from. Doesn't seem like anyone wants to put in the chat. Okay, some AutoCAD. No generative, which is fine. Generative is fairly new technologies you're going to see. So sometimes we do run across students that have it, which is great. So again, feel free to type that in as we go, and I'll keep an eye on that. All right, so real quick, so those of you that weren't able to attend last week, I just put in a couple slides here just to talk about Fusion. So Fusion is an end-to-end product platform, anywhere from the parametric design, simulation. If you ever don't need to do PCB boards, electronics, we can do that inside of Fusion, the manufacturing. And that's what we're going to do tomorrow in this time slot. We're going to take the phone stand holder that we designed last week, and we're going to create the toolpaths, as you can see down here in the lower right-hand corner. So I'm going to show you guys how to do that inside of Fusion. And then everything is cloud-based. So all of the files that you saved inside of Fusion are saved in the cloud, so they're easily accessible. This is where we get real-time collaboration. We don't have to set up servers or anything that you would have to do with traditional desktop CAD softwares. And then again, if you haven't already downloaded Fusion, you can do this for free. Just go to autodesk.com/education, and you're going to create your Autodesk account and verify that you are a student. And then once you do that, you can download, install Fusion. And Fusion does install natively on Windows and Macs, just so you are aware, which is pretty cool. Now, into our main presentation. So what is generative? So generative design is all about design exploration. So again, we're using artificial intelligence, and we're sending this data up to the cloud, and we're going to start getting multiple iterations back after we go back and we define the problem in its entirety. So again, the big takeaway here, from this whole presentation, what's generative? It's all about design exploration. Again, usually coming up with designs that you wouldn't come up with by yourself. Again, these are going to be based on strong engineering and manufacturing principles as well. So now that we talked about what generative is, now I'm going to talk a little bit about what it's not. So there seems to be a lot of confusion in the market with some of our competitors saying that they do generative design, but they're really doing topology optimization. So inside of Fusion and all of the Autodesk products like Inventor, we can do topology optimization as well, where topology optimization will take an existing component part and it will show you where you can remove material. That's what shape optimization does. So it's going to be based on the load cases that you put back in. It's not taking a look at manufacturing methods or anything like that. You're, again, going to get a result for that one component, where again, with generative, you're going to get multiple iterations back. And again, that's going to be based on strong engineering, manufacturing principles. And at the end of the day, when you figure out which one of those iterations you want, you can export a solid model. And basically, I refer to this as getting the recipe. So once that file is exported, you can go back and make edits to that as well. Any questions so far on topology optimization versus generative? Nope. Okay. All right, so where can you use generative? So a lot of our customers are using it, of course, for new product design, coming up with brand new concepts. You can also do it for part consolidation. So if you have an assembly, maybe, or a sub-assembly, maybe it's 8, 10, 15 parts. What would that look like if we were able to combine those together? So we see companies getting a lot of enhancements from their productivity by doing that. And of course, then we have the part enhancement itself, right? So if we have a part that is failing in the field, generative design could be one good way to go back and alleviate some of those issues. So here's the workflow. So we're going to go through, and again, I'm going to show this to you guys live in a little bit, but we're going to go through, we're going to define the problem. And basically, you're going to learn some terms here. So we're going to have our preserves and our obstacles. So that's going to be geometry that needs to be maintained and areas to stay out of when it's growing our geometry. And again, then we're going to define, the potential manufacturing side. So is it going to be, could it be 2 axes cut or a 3 axes? Is it going to be additive? Is it going to be die cast? We're going to add our load cases. How's the part going to be loaded? You can define up to 7 different materials. And then we send that up to the cloud. Then we, again, get multiple iterations back. And then again, I'm going to show you some tools that we can figure out of all those iterations, which one would be the best. Export that, and then you can go right to manufacturing. So that's the process we're going to follow. Now, the advantage to doing generative is you can see here on the screen. So right now, again, kind of looking at the screen, bunch of CAD experience already on the call here. So if you were given a design problem, maybe put in the chat here, how many iterations do you come up with before you start to design? So again, if we know that, we're going to design this little like this phone holder that we did the other day, how many iterations would you come up with before you actually started going down the final path? What would be a number? If anyone wants to play it, put it in the chat, just a number. 2 designs, 1, 10, 5. So a couple ones, yep. And that happens a lot, right? We get one idea and we start designing and we just go down that path. Well, with generative, again, we're not going to just be defined to the one idea that we have. We're going to define the problem in its entirety. Again, those preserves and obstacle geometry, defining our load cases, how this could be manufactured. And we're going to condense that, as you can see in the slide here, which again is going to make companies way more productive. Now, again, from a student perspective, as you guys start to interview for internships and jobs, knowing generative design can be a big differential for you in that interviewing process, right? Where you can show a company that you can bring new skills to the table. That's a wonderful thing. All right, so again, the manufacturing methods that I was talking about. So this can be a little confusing if you've never seen this before, right? So when we go through the generative process, basically what we're stating is, give me some outcomes based on these different manufacturing methods. Again, we're not saying that I will do a 3 axes or a 5 axes. All we're telling the system here is, what would it look like if I were to go back and I wanted to do a die cast? Give me a result for that. Now, I also want to introduce a company called Priori. So when we're going through the generative process, we can come up with great designs, but it may be cost. Well, the cost could be an issue, to be blunt, right? So if we come up with this and it costs $500 for an additive component, the company's going to say, yeah, that's great, but we can't do that, right? It's way outside the boundary here. So we partnered with this company, A Priori. And what you'll do here is you'll actually place in the number of parts that you want to do in a run. Maybe it's 5,000 or 10,000, or maybe it's just 2, right? And you'll get a cost estimate for that part, again, based on the material and the manufacturing method. So then you can go back to the company, and when you do this and say, I believe it's going to be right in the range of, $30 to $50, for us to mill this component, something like that. And that's, again, coming from this A Priori. Just in case you see that, you'll know where that's coming from. Now, here's an example. This is a company called MJK. I'm not sure if anyone on the call drives a Harley Davidson, but this is for a triple clamp for their front end. So you can see that they came up with, on the left-hand side, what the designer came up with, the engineer, versus 2.5 axes, 3 axes, and additive with generative. And of course, as we go back to the further to the right, things are going to get a little bit more expensive. Currently doing 3D metal printing with metal is expensive. And of course, I believe that those costs will be coming down as the technology evolves. But again, you can also see where the mass is being reduced, and you can see where the safety factors are. So again, based on really strong engineering principles. So now you're going to see me with generative. Of course, you can design the components fully inside of Fusion, but if you have a component apart from SolidWorks or Pro-E or Inventor, we can work with those components, bring those into Fusion, and again, create our preserves and obstacles. Does anyone on the call have experience with ANSYS? Again, we can just use the chat. Yes or no to ANSYS? No. No, 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 no. Okay. So I know there's a bunch of schools that do use ANSYS. So we have a strong partnership with ANSYS. So if you were using ANSYS, you can actually take the simulations when we're done, and you can re-verify them inside of ANSYS Mechanical if you had it. But it doesn't look like that's going to be the case here. Okay, so here, let me just talk about what's going to happen next. So what I want to show next is going to be a video that's going to walk through the process. All right, so again, this is going to be for that triple clamp. And again, the first thing we're going to do is we're going to define our preserves and our obstacles. And then once we define those, then we're going to define our load cases. Again, where is it going to be fixed? Where the load's going to be applied to. And again, you can apply as many load cases with generative as you need. And then what's the result going to look like? How do we know what success is going to look like? Is it just a safety factor? Is it stiffness? Then here's the manufacturing method. So again, at the top, you can see the production. That was the a priori stuff. Again, we're just setting it back up. What are we potentially tooled up for? And then we send this up to the cloud, and probably maybe 2 or 3 hours, we'll see the end results for this. And again, you can see that we have we have 30 different outcomes to look at here, or in this case, I'm sorry, over 120 outcomes that we're looking at. So again, I'm going to show this to you guys live in a little bit, where we can figure out, out of all of those, how do I know which one is best? And again, when we export this, so here's the model exported. So again, we give you the recipe. So based on the outcome, you can go back and you can make changes to that model. And then again, we can finish up, we can rerun the simulation, or in this case, we're also taking it to create Toolpath. And again, this Toolpath, this is what we're going to cover tomorrow. So now, we're always asked, well, generative is fairly new. It's about 2 years old technology. What's happening in the industry? So again, I'm not going to read these to you, but you can see that generative is getting great reviews, from, the technology sector, which is great. People are definitely seeing this, helping us out with Industry 4.0, closing that gap. These are some of the industry segments that are using it, right? So you can see all the way aerospace, automotive, medical, industrial, consumer, dental, oil, gas, architecture, construction. So the latter, may be a little odd to see that, but right. But if you think about, what's happening inside of buildings, right? It's a structure, right? So really, it's the same principles here. So generative can solve many an issue. Now, some companies that are using generative, so Honda, so again, really large company here, but they're definitely seeing generative as the way forward for them to go back and get a competitive edge. So again, MJK, we just looked at these guys, again, a pretty small company that's seeing generative, but we can see some of the results that they're getting from generative from those previous slides are pretty amazing. Company like Airbus, so of course, Airbus does the planes, right? So every ounce that we can reduce for mass is going to allow the plane to go further, which is a wonderful thing. And then another example here would be Claudius Peters. So this is an industrial equipment manufacturer over in Germany. So again, you can see the results that these folks got from generative design. Again, as a student perspective, right, if you can go back while you're interviewing and, show projects that you worked on, that you could go back and start to reduce costs. If you could take a component and reduce $7,000, per design, that's a lot of money, right? So the last thing I wanted to also show you guys here. So, and again, you can take a picture of the QR code, but with generative, it's just not commercial folks that are using generative. We have students that are also using generative and getting some really cool results. So if you click on that QR code, it's going to take you out here. And let me click on this. So again, these are some stories based, of course, on automotive designs that students have worked on. So I think it's pretty exciting to go back and see, not only what industry is doing, but what's happening in academia. So some really cool stories. Again, you guys can go back and click through these pretty cool things that are happening in industry. So your peers are already using generative design. Did everyone take a picture of the QR code that needed it? Assuming so. All right. So now, before I dive into Fusion and walk everyone through the process, so as I mentioned before, you go back and you create your Autodesk education account. When you create your account, use your university.edu email address. And the reason you want to do that, because if you sign up with a Gmail account or Hotmail or Yahoo, you will not get access to generative design. So you must use your .edu email to get generative design. If you use Gmail, you can still get Fusion. You just won't get access to generative design. And then when you go back and you start to create your designs with generative, it's going to ask you about cloud credits. So a cloud credit is another way basically of saying $1. So one cloud credit equals $1. So when you send these up, it's going to say 33 cloud credits. So I just want to be clear, that is what our commercial clients are paying. When you're logging into Fusion with your education account, there is no exchange of money, right? Think of this as Autodesk investment in your education. So again, you're going to click through where it says 33 cloud credits, to create the generative design. And then when you want to do an outcome, I believe it's 100 cloud credits to actually get that outcome. So again, you're just going to go ahead and click OK. And you're not going to, okay, we're never taking a credit card from a student. So with that, before I dive into Fusion, does anyone have any questions on anything that I presented? Feel free to unmute yourself. Everything crystal clear? No questions? Everything I said was totally crystal clear? All right. Let me go over to Fusion here. So here is a control arm. So I'm not sure if anyone on the call is on like the Formula SAE team or the Baja team, but this would be part of that front suspension. And as you can see with generative, all I did is I basically created a really simplistic design to represent, the dimensional information for this control arm. So now here's where we're going to go. So remember early on, I talked about Fusion is a platform. So under the design workspace, I'm going to switch this to generative. And again, I'm just going to walk you guys through the process real quick. So the first thing that we do is we define our preserves and our obstacles. So obstacles are red. And again, this is going to be the area where when we're doing the generative design, do not add material here. And the preserves, this is going to be the area when the model is complete, these need to be maintained. So in this example, these 3 cylinders, these need to be kept, right? Because we're going to have the bearings and the pins go through here. So that's a requirement. But of course, what we don't want is we don't want anything growing where the pins are going to be going through. Now, how do we do that? Is we just come up here and we just click and edit model. And we give you tools inside of this environment to go back and create the geometry. And again, I'm not going to do this for you in the entirety here, but again, we give you tools like an obstacle. So for example, if this was going to be a hole, I could place that back in, set this back down, do the bolt head on both sides. So you can see whatever I'm defining here for that keep out area is happening in real time. So again, really quick, really simple tools to go back and create this geometry. And of course, you can also do it like you would be doing traditionally. So here you could create sketches and do extrudes and revolve. So again, we give you great tools for doing that. And then again, we're just following our way left to right. So we did edit model. This is where you define the preserves and the geometry, just selecting those. And of course, I've already done that, so I won't do that again. And then we go through and you define the load cases. So this is probably the hardest part with generative design. And the reason I believe it's the hardest part is we're trying to predict how this part is going to be loaded before the part's really made or manufactured. If it's a new part, right? If it's an existing part, you may have load case information that you could input, and that would be great. So in the example here, you can see that I created, I believe, 9 different load cases. So I'll just walk you guys through this one. So here are loads. So I got gravity, and you can see that I have a force of 250 pounds coming straight back out. And then I have it constrained, just so you know. Fix this, and this is going to be fixed down at the bottom where the bushing, where this would actually sit on top of that bushing. So again, I just worked my way through. And again, we give you some really easy tools. Once you have one load case defined, you can come back and you can clone it and then go back and make edits to that. And that's what I did here with the existing load cases. Again, so this isn't necessarily going to be loaded at the exact same time for this control arm, right? The forces that are going to be applied, as the vehicle is moving, it's going to be forced, or the forces will be applied in different orientations. Again, that's what I'm setting up here. So again, let me pause because that was a lot right there that I just talked about. Any questions? Anybody? Can you load torque? So the question, that's a good one. So if we come back up here, not constraints, loads. So we have forces, pressure, moments, and bearing load. So I'm assuming that moment would probably be the torque load, Graham? That's a great question.
Yeah, that's what I was thinking.
Yeah. So the other thing I should mention, right? So Fusion 360 is unlike other CAD systems. Anyone want to take a shot at how often we update Fusion 360? And we'll put in numbers in number of weeks, right? So traditionally it's, every 52 weeks, once a year. How often do you guys think Fusion 360 updates on average? Any takers? Anyone want to guess? It's a Monday. So it's every 6 to 8 weeks. Yeah, so 12 times. So yeah, that would be about right. So about every 6 to 8 weeks, we send out a major update. There might be some minor updates in between, but real big functionalities being added are every 6 to 8 weeks. And the reason that I want to say that, right, is we're always continuing to add to generative design. So if you're not seeing something today, when you log in next week and it's there, it's a wonderful thing. So just so you guys are aware of that, say, well, that wasn't there last week. Well, maybe we pushed out an update and that's going to be there. All right, the next one is objectives. So how do we define success, right? Do I want to minimize the mass? And we have safety factor. So those of you that don't know about safety factor, here's a 30,000 foot look at safety factor. So let's say that we design a table to hold 100 pounds for simplicity, and we put 100 pounds on there, the table is good. We put 101 pounds on there, it breaks with a safety factor of 1, right? If we have a safety factor of 2, if it could hold 200 pounds and less, 201, it would break. So again, that's what safety factor is at a real high level. You can also figure out if you want to maximize the stiffness, then you have to put in your target mass. So again, I'm just going to keep mine here to minimize the mass, safety factor 1.5. Then we have the manufacturing methods. So again, this is all about what if, right? What would the design look like if we were to do these? So let's just walk through these real quick. So again, the cost estimation. So this is the a priori. So here you can say I'm going to do a run of 5,000 of these control arms. So that'll give me good cost for that. Then we have manufacturing called unrestricted. So I'm guessing everyone on the call has probably never heard of the unrestricted manufacturing method. So what unrestricted goes through, it goes back and it starts to create geometry, and it's not taking into account any manufacturing method like 3 axes or die cast, any of that. So why would you do that, right? So think about inspiration. So unrestricted could come up with some really different designs that you would never have thought of before. And then you could go back and remodel those separately if you wanted to. But also with unrestricted, with today's technology around additive manufacturing, there's very few unrestricted parts that I've seen that could not be made with additive manufacturing. Then that takes us to additive. So we have different orientations. So with the different orientations, again, I'll go back to my model here. When we're going to 3D print this, how do I want it built, right? Across the bottom plane, the side, or the front, right? So here you can say, or you can see that I selected 4 different orientations. And again, that's going to give me 4 different results for the given material for that component. And again, we have the overhead and the minimum thickness for the parts. Again, you're going to place in that really based on your design and the machine. Then we have the milling. So here you can see that I've already set up 3 different mills. So 3 and 5 axes. Maybe I need to take a step back here. Real quick, does everyone on the call, anyone have experience with CAM? Maybe we should have done these in opposite orders. Maybe we should have done the manufacturing webcast first and then did the generative. It doesn't look like we do. So real quick, right? So 3 axes, what a 3 axes does is the mill can move down in the X, Y, and Z simultaneous, hence 3 axes. And with 5 axes, usually the raw material can move in 2 different orientations. And that, of course, will give us 5 axes. So with a 5 axes versus the 3 axes, it reduces the number of setups, basically the number of times that you need to remove the material to cut it. So for example, if I'm milling down here, and now if I need to mill this pocket out, you know, if it's a 3 axes mill, I'm going to physically have to take that material out of the vise and turn it. So that would be a second setup. With the 5 axes, we could just flip the material and then I could cut it. So that's an advantage to 5 axes. And then again, I'm defining the tool direction. And then the tool diameter, and let me minimize some of these so we can see these a little bit easier. And then we have 2 axes cutting. So you'll see that it's unchecked in this example. So the reason that it's unchecked for 2 axes, you need to have a unified thickness for the material when this is cut. And of course, in this case, you can see that that's not the case. If I switch this over to the front view, there are different thicknesses already to start off with. So I'm not going to get a result. So hence I didn't check that. Then of course we have die cast, right? Where we create a mold and you pour really hot liquid into that and it solidifies and we get our component. So that's where we're at with the manufacturing. Then we have materials. So you can define up to 7 different materials for the generative study to take a look at. And here, again, we have unrestricted. So here you can see all the different materials that I've applied. And when you see the calculator in there, that tells me that I'm going to get a cost estimate from that a priori software. So again, unrestricted. So we have additive. So you can see that I just have 2 different metals from the additive library. Milling. So I got steel and titanium. And for die cast, I did aluminum and steel cast. Again, you don't have to apply 7 different materials, but again, all about design exploration, right? Because you can have great designs and the material that you use will have a big effect on the components. With materials, the only thing I want to add here is currently we're only working in single direction with our materials, like a mono material, something like carbon fiber, you know, that would be multi-axis, and we don't currently support that. So just so you're aware of that. Then we take a look at our pre-check. And here again, these warnings are basically stating some of the materials that I selected, they are not going to give me a cost estimate. Remember, it didn't have the calculator in there. So I'm okay with these warnings. You know, if I had a major warning, if I, for example, I missed selecting a preserve, it won't allow you to move forward. It'll be red and you'll have to fix that. So don't bypass these. Take a look at them for sure. And then the next step here is to do a preview. And it's going to take a look at our geometry here, and it's going to show me potentially where the material can be added. And again, what it's going to be staying away from. Again, so this is going to take about a minute or so, but I'm going to let it run. So this would be a great opportunity to ask questions. Surely someone's got a question. Surely? Anybody? Is there a plan to add multi-axis material support? So what I should have done is I should have put a safe harbor slide in. So Autodesk is a publicly traded company. So here's going to be my safe harbor agreement, right? So Autodesk is a publicly traded company, right? So don't buy stock based on what I'm going to tell you here. This is not a promise that we will deliver anything, but having multi-axis material is something that we absolutely are aware the market needs. So when that's going to happen, I can't tell you, but we are well aware that we want to do that. There's a lot of things that we want to do. And a little bit, I'll also show you guys some things that you can take a look at, where we're going, kind of give you a good idea, on what's on our short-term roadmap. All right, so here you can see that the preview is coming back here. Again, what I'm looking for here is, where the material could potentially grow. Again, so I don't want material going through where the pins or the bushing is going to go, so we're good there. But again, if I go back to that front view, am I concerned that there is going to be potential material growing at the bottom? If so, then I would need to go back and I would edit the model and I would add in another obstacle there. All right, so now we'll stop that. Then the next thing we would do is we would generate this. And again, once we would generate this, it'll ask me about the cloud credits. And being that there's nothing here to solve, it won't allow me to do that because I'm already in a solved state. But again, right here, it'll say 33 cloud credits. You can just go ahead and click on generate. And again, no cost to you. But what I'm going to do now is we're going to fast forward, let's say, 2-3 hours. And here are my results. And by the way, as those results are being generated, you can see these growing, which is pretty cool, right? They're all going to start off basically with, rectangular material, and it's going to start removing material. So pretty interesting to watch. So now on the left-hand side, we have converged and completed. So converged means that the results met our criteria 100%. We have completed where we have results, but there may be an issue somewhere. Maybe we didn't hit the safety factor, or maybe it's not as stiff as we were intending it to be. So again, it's going to show us the results, but just be aware that we're not 100% on our solve. All right, so now on the bottom side here is you can also isolate, say, only show me the additive. And here, let me select multiple of these. And let's preview these. So remember when I was doing additive, we were talking about the different setups. Again, how is this going to be built on the Platinum? So on the upper left-hand corner, you can see the orientation is the X. This one is the Y. Lower left-hand corner is Z plus. And the Z minus. Basically, it's affecting, what's the flat area. But as you can see here, you can zoom in, see the difference between our iterations here. We can take a look at it from a stress view. You can remind yourself, show me where the preserves and the obstacle geometry was. So those are good reminders. And as long as I'm here, I'm just going to close off a couple of these. So with the build in the X positive, down at the very bottom of the screen, you can see that it went through 56 different iterations. Now, I'm not going to painfully take you guys through all 56 of these, but you can see iteration 10. We can see where the mass is, 22 pounds. Yikes, pretty heavy, right? Safety factors coming back down 1.76. Here, let's just switch over to maybe 40. So mass, huge decline down to 5 pounds. Now, the reason I'm showing this, right, again, so these are the different iterations that will be shown on your screen as you run through the process, but you can also, at any one of these iterations, you can export any one of these iterations. So again, if I say, I really like iteration 50 a little bit more than 56, that's totally up to you. And then all you need to do is come back up here and you would export a design. And again, this will give you the solid model. How many different materials do you typically test when doing these? So I usually try to use all 7. So usually I'll have some materials for additive, versus milling versus die cast, so I try to do, the limit of 7, but you don't have to, right? If you only have access to maybe 2 different types of aluminum and steel, then just use that. So you don't have to use all 7, but again, I'm all about, trying to figure out what's that possible outcome going to be. So the more materials, the more iterations I have to look at. Do you need to have Fusion open while they generate? That is an awesome question. So while you send these up to the cloud, you can close Fusion. And when you come back, what you're going to do is you're just going to open up the file. And then just like I did here, you just go back and say, show me the outcomes, and they'll be waiting for you. So yeah, Fusion, it doesn't have to be open. You can close it as soon as it's sent up to the cloud. That's a great question, Graham. I think I answered all the questions. If I didn't answer your question, feel free to retype it in, but I believe I'm up to date. All right. So again, that's how we're going to do the export. But let me just show you a couple more tools, right? Again, you can figure out on the left-hand side here, show me, the 5-axis milling. Just show you one of these so you can get a contrast and compare. So a little less alien-like, right? There are 5-axis milling, but again, pretty cool. Probably something that I wouldn't come up with as a design on my own. And let me reset these. Across the very top, you can also show the properties of each of these iterations. So you can scroll through that. You can also do a scatter plot. I'm sure everyone on the call loves doing scatter plots, but you guys will love these. So here you can say, I believe, I want to stick to, the outcomes, that met the criteria in the lower left-hand corner of the scatter plot. So now when you click on each one of these, you'll see the results for that. So that's another really good tool. You could do a table view if you want. Now, one of the bigger requests that we got from folks is, this information is great on the screen, but it would be awesome if we could take that information and get it into an Excel spreadsheet where we can analyze that. So before I was talking about how fast Fusion updates, this is an update that actually came out, I believe it was 2 weeks ago now. So being able to export that data to a CSV file, which is pretty cool. Then, oops, sorry, let me go back into the Explorer. I want to show you guys one more thing. Go back here. We can also cross the very top, let me expand this, is have recommendations. So across the very top, how did we figure out to recommend these 4? Well, you're in control of that. If you come back up here, you can customize that. So what's important to you? So low mass, we'll say, let's make that really, really important safety factor. Again, this is going to be a critical component. So let's make that high displacement. Let's say, for cost, at this point, maybe I'm not too concerned about the cost. And if anything changed here, you would see these get updated in the recommendations. So again, I just wanted to do a high-level overview so you are aware of that. Any questions on anything about the outcomes? If not, I'm going to fast forward. So once we take one of those iterations and we export it, like I did here. So this was for a 3-axis mill that I exported. So again, you can see, looks really pretty cool. Again, something that I would probably not design on my own, right? But when I started doing the beginning of the presentation, I talked about, Fusion 360 giving you the full recipe. Down in the bottom of our timeline, that's what we give you here. So let me just get into the T-spline area. So the T-splines, basically, as you can see here, this is how we connected our preserved geometry. So for example, if you wanted to make an edit to that, you can take that, you can grab faces, edges, points, and you can pull them out. And in this case, I'm not sure what I did. I rotated it. So let's do this one. So you can see, you can pull it, drag it. We also give you tools under the modify menu. So if you want to fill in gaps and holes, you can easily do that. And then once I exit that environment, right? So let's say we come back here, I can now come back and I could maybe add some additional fillets or holes. Again, whatever you need to do, to finish this model, it's your design, right? You're co-designing with the cloud. So this doesn't have to be the end result. Feel free to make additional changes. But then let's say we do make some changes. I'm now going to go back and I'm going to change my workspace to simulation. And what I would simply need to do here is rerun it, because you'll notice on the left-hand side, all of my load cases came over. So everything that we input in generative design is now being able to be retested here. So all I would need to do, come back up here, click on solve, and the same deal. So I can solve this in the cloud. With generative design, you don't have an option, by the way, to solve that locally. Way too much computer processing power is going to be required. So generative has to be done in the cloud. But with a simulation of static stress like this, we do give you the option to send it up to the cloud or locally. Again, if you do send it up to the cloud, you're going to, again, see this cloud credit. It'll say 5 cloud credits for a simulation. All you need to do is click on solve. Again, no payment is going to be requested of you as a student. And again, I know no one on this call seemed to have ANSYS experience, but let's say you're on an internship, you get a job and they do use ANSYS. Again, you can take any simulation study from Fusion 360 and you can export this to ANSYS Mechanical. And again, all the load cases will come with that. And then the last step that I want to show, and again, this will kind of be a little prelude to tomorrow, by the way. So if I switch my workspace to manufacture, this is where we're going to create the toolpath. And you can see that I've already set this up. So the rectangle represents my raw material. And then I quickly created just a roughing toolpath just to show everybody what this is going to look like. So when I simulate this, let the dialog box pop up, play this. You can see that it's going to start to remove material. I'm going to run this a little bit faster. And again, tomorrow, same time, so 1 Eastern, we're going to go through, we're going to create Toolpath on how we did our little phone stand that we designed last week. So while this is running, we left 10 minutes here for any other questions. So again, feel free to unmute yourself, put it in the chat. No questions? All right, then I'll ask you all a question. Is this helpful? Do you see where generative design is going to be useful for you as you're working on projects? Yep, Very cool. Yeah, generative, it's a game changer, right? As we go from, industry, I should say, as industry advances, right? We went from, 2D CAD to 3D, generative design definitely is that next step and allow us to do some really cool things. All right, so now here, let me just talk about just a couple other little things here. So let me exit out of that. So the question came up about, what's Autodesk working on? In the top right Fusion, if you click on your emoji and then preferences, we'll let this pop up. Down on the lower left-hand side, I'm going to click on preview features. So this is functionality that you can see that we are currently working on, and we're trying to get some feedback on. So with generative, as you can see, so diecast that I showed, so that's in preview. We have an experimental solver and fluid as well. And there's some really cool things that are happening with the new solver. We're going to get some more multi-physics in there, which is some pretty cool things. But again, you can see there's a lot of things that we are working on. Not quite ready for prime time, but pretty close. And we're looking for feedback. All right, and does Autodesk offer courses on Fusion 360? Perfect lead in. That was the last thing I was going to show. So there's a couple things here. So first, if you go under the help, and then first thing you can do is you can show the learning panel, by the way. And I'm just going to start up a new design. And with interactive on, as you start to learn Fusion, right? So if I go back and I create a sketch, you'll notice that the tool set changes. If I go to the circle tool, the tool set changes to circle. If I go to extrude, we're going to give you interactive help based on that. So that's the first thing I wanted to show you. So that can be very helpful as you're just starting to learn Fusion. But if you're looking for courses, so learning and documentation. So there's self-paced learning, which is really good. So this would be a great place to start. And if you're looking for longer courses, just search for Design Academy. So that's where Autodesk has learning content as well. And I'm not sure if anyone here has taken EGR 100, but Fusion is starting to get introduced in that class as well, which is pretty exciting. Does that help, Nicholas?
Yes, thank you.
And the other part is so we can come back, in the fall, and we can do, a deep dive in generative, a hands-on workshop. So this fall, we're going to also have multiple students as student ambassadors. So you'll hopefully be hearing a lot more information. So maybe when we get those scheduled, Rachel and Garth, maybe we can contact you, maybe help spread the word about those workshops. Thank you, Rachel. All right. Does anyone else have any last parting questions? If not, I think we're going to finish up 5 minutes early. Garth, Rachel, is there anything else that you want to add?
I think this is perfect, Dan.
All right. And so again, maybe just a hair of a preview for tomorrow. So tomorrow, everyone's going to see how organized I am with my files. So tomorrow we're going to finish off the phone stand that we modeled up last week. Dun, dun, dun. So that was my wonderful phone stand. And again, I already milled this last week, so I know that it works. So again, tune in tomorrow and we are going to walk through how I actually created the toolpath for this guy. So even if you're not going to become a machinist, which you're probably not, right? Knowing good manufacturing principles will make you a better designer engineer. No doubt about that. All right, so that's my little preview for tomorrow. So same time, right, Garth?
That's correct. 1 o'clock right here.
All right.
Same bat time, same bat channel as we used to say when I was growing up.
Absolutely. All right, I'll be here sitting on the bat phone.
There you go.
All right, everybody. I hope that's helpful. And again, I'll try to join a few minutes early tomorrow if anyone else has any other questions that we covered today.